how can the hardware detect conflicts between two transactions and between a transaction and non-transaction modification? It turns out that almost all shared memory multiprocessors already have most of the support needed. There are some extensions required, but the second level cache and the cache coherence protocol are ideal for detecting conflicts between caches, and it can be done as I will explain now. So for the blue gene, recall that each thread stores a version identifier or tag near each cache block that it has modified. Okay, and then the accesses are marked as being reads, writes, and also whether they are speculative or not. Speculative meaning that the memory access belongs to a transaction that may be aborted. Okay, so how can now the cache, this mechanism detect conflicts? It is by also storing which other threads have accessed a certain cache block. And by knowing this, we can detect, the hardware can detect that there are two threads, meaning transactions, that have accessed the same cache block, and at least one of them has modified that cache block. And then it can trigger that a transaction should be aborted. For the blue gene, there are two modes of operation. Okay, and first of all, the blue gene was not using hardware that was initially done for hardware transactional memory. These were additions that came after the CPU designs. They didn't start from scratch with a CPU to do this, but to do the blue gene supercomputer. As we will see on the Power 8, they could do it from the beginning, so to speak. Okay, so the implementation of hardware transactional memory on the blue gene has some overhead which is not needed for Power 8. And one such is that starting a transaction and also committing one involves the operating system, which is a huge performance loss compared to not having to involve the operating system. Okay, and due to this, it was identified that it's better to offer two alternatives of transactions. One that is expected to, one option is to have short running transactions. It's not that the transaction will stop after a while, but they can be selected and the machine behavior is optimized for transactions that are short. And the other option is to set machine parameters that optimize for long-running transactions. Short and long means the number of memory accesses. Okay, and the granularity of detecting conflicts is a cache block, and for this machine 64 bytes. I usually use the word cache block, but cache line is a synonym, and it can, sometimes it's used, but usually I use cache block, but I will also use cache line.